Hello guys, this lesson is for week 6, Tuesday through Friday. It's within the same lesson, complex numbers. So you guys have learned about complex numbers before. That's the one where if we have x squared equals to -1 and we ever try to solve for x, we want to square root both sides, right? And the square roots and the square get canceled out, so I have plus or minus square root of -1. But remember, square root of -1 in the real number sense, this is actually undefined. So it's like technically not possible to have that in the real number system. But if we have the complex number system, this is actually valid because complex numbers include all of the imaginary numbers, which we will get into the letter I. Okay, if I have I squared equals to -1, then it will be valid because I represents the imaginary. Okay, so I'm going to write this on the side. Remember, I equals to square root of -1, but most of the time we actually just refer to I. We don't really use square root of -1. And if we have I squared, that equals to -1, and we write it like -1. I to the third power, that's negative of square root of -1, but we write it as -I. And the last one is I to the fourth power. So I to the fourth power is really a -1 times another -1, which equals to +1. Okay, so these are my main answers whenever you have I to a certain power. So if I have I to the, let's say, 10th power, I can just kind of keep counting. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So technically this is our answer for I to the 10th power, which is -1. And to get that answer, we went from I to the 8th power times I to the 2nd power. Because I to the 8th power, it goes away. We really only have I to the 2nd power left, which is -1. Okay? If it's I to the 10th power, it's so easy to just count like this, right? But what if you are asked to do I to the 200th power? We don't have time to like just count like this, right? So we want to figure out, we want to check whether 200 is a multiple of 4. If it is a multiple of 4, then we can just go straight to 4 and that's my answer already. But if it's not, we got to see how much remainder we have left. Okay, so let's go to 200 first. 200, is that divisible by 4? 4 times 5 is 20 and 0. So yes, it is divisible. We don't have any remainder. No remainder. So this answer is technically just 1 because it's a multiple of 4. We only look at the last one. Okay, so let's look at another question. Let's do I to the 205. Okay, is 205 a multiple of 4? So if 200 is multiple of 4, the next number that's divisible by 4 would be 204, right? So that means my remainder would be just I to the first power. So what's I to the first power? It is just I, because this goes away. Okay, one more example. Let's do I to the 282. This is an even number, 282. So it can possibly be divided by 4, or it can be the remainder. Okay, so let's check if it's 282 is divisible by 4. 4 times 7 gives you 28, remainder of 2. So I'm always going to have a remainder of 2. So I'm going to have I to the 280 power times I to the second power. I to 280 goes away. I to second power is -1. Okay, you'll have a question like this in your homework on one of the, I think it was like Wednesday or Thursday. Okay, so I kind of did a lesson on the side. Now let's go back to writing complex numbers. I have complex numbers. We usually write it as A plus BI, where A and B are real numbers. Okay, I will write some examples later to show you what it means by complex numbers. But let's first off talk about some rules. Let's talk about addition and subtraction of complex number. So whenever you want to add a complex number to another complex number, I would use A plus BI, adding C plus DI. You always want to group up. It's really just like combining like terms. You want to add up your like terms together. So in this case, the ones without i's are your A and C. So we want to add up our A and C and add up our BI and DI. Okay, so example, if I have a 2 plus 3i, adding a 4 plus 5i, your answer in this case would be add your 2 plus 4 and then add my 3i plus 5i, which we get 6 plus 8i. Okay, pretty straightforward. Now let's do subtraction. If I have A plus BI minus C plus DI, your negative will just distribute. So I would have A plus BI minus C minus DI. And that's subtract our A minus C, and then we subtract our BI and DI. Okay, one more example. If I have 6 plus 3i subtracting 2 plus 8i, then our negative would go into our 2 and 8i, which we get 6 plus 3i minus 2 minus 8i. Combine your like terms, we have 6 minus 2, which we get 4, minus 5i. Okay, so that's it for adding and subtracting. We're now going to get into multiplying. So let's look at multiplying or multiplication of complex numbers. So if I have A plus BI again, I multiply C plus DI, you're going to do your distribution, which is like FOIL. So I'm going to multiply A times the first and times the two terms in the end, which is A times C plus A times DI. And then also do these two, which is BCI adding BDI square. Okay, I just put the letters in alphabetical order. And then we're going to see these ones are the ones with the i's, right? So any of them that only has the I with the first power, you can add those together. Then I put my I right here. Okay, but what about What about the I square? Remember I square, we always turn that into -1. Okay, which makes this term right here to be negative BD because I'm multiplying a negative to the BD makes it negative BD. Okay, so right here, we're going to be writing AC minus BD because there's no more I and they're like terms now. You can combine them together. Okay, let me show some example. Let's do 2 examples for now. This one, 3I times 5I, and let's do 2 plus 3I times 4 plus 5I. Okay, for the first one, multiply your number times number, which we get 15I squared. Remember, I squared turns into negative. This makes a -1, so my final answer will be -15. Okay, next question. I have my 2 times each of those, and I have 3I times each of those. So we get 8 plus 10I plus 12I plus 15I squared. Okay, so with what we said earlier, our I squared turns into -1. So we make this whole entire term -15. Okay, combine your electrons. We get -7 plus 22I. All right. Some more example that will help you for your homework. Let's do 5 minus 2I squared and 5 plus square root of 6I on the outside square. Okay, so if you have a square to, at the top of the parentheses, remember you always want to rewrite your 5 minus 2I times 5 minus 2I. And then you do your multiplication. And if they're exactly the same thing, we can multiply our first times first, which we get 25. Okay, and then when I multiply the next one and this one right here, it's the same thing. So if you kind of know what I'm saying right here, when we multiply these two together, we get like -10I and another -10I, right? So we really just double one of them, okay? Which in this case, if I double one of them, will be -20I. So it'll be -20I right here. Okay, again, our first arrow was 25, and then we have -10I, -10I, and our last arrow would be plus 4I squared. Okay, plus 4I squared really is -4, because this turns into negative. So our final answer here would be 21 minus 20I. That's it. Let's check the next one. 5 plus square root of 6I, 5 plus square root of 6I. Multiply first times first, we get 25. And if I multiply this one right here, we get 5 square root of 6I. And we have another 5 square root of 6I plus the last one is square root of 6 times square root of 6 is just 6I squared. Okay, so we have 25 plus 10 square root of 6I minus 6. We get 19 plus 10 square root of 6I. I stays outside of the root. Okay, so that's it for multiplication. And since this is like a 4-day lesson, it's going to be longer than, actually, it's not long of a lesson because you guys have kind of learned this before. So we already talked about adding, subtracting, multiplying, and now we're going to talk about one last thing, which is complex conjugates. So complex conjugate, whenever we talk about conjugate, we have, let's say, 5 plus 2i. I draw a line on top. Oops, we draw it better. Whenever we draw a line on top, when we say we want to find the conjugate of this, we always want to do the opposite in the middle. Okay, the first term stay the same, but the second term we do the opposite of that. So the conjugate of 5 plus 2i would be 5 minus 2i, because whenever you multiply these two conjugates together, the I goes away. Okay, I'll show it to you right here. 5 plus 2i times 5 minus 2i. When I multiply this together, 5 times 5 goes 25. And the middle terms, negative 10i and positive 10i, they cross out, right? And my last one would be negative 4i squared. And then negative 4i squared becomes a plus 4. So it'll be 29. The letter I goes away. So that's why conjugate is very useful to get rid of the i's at the bottom. Okay? So again, if I ask for 6 minus 1/2 I, what would this equal to? It would just be 6 plus 1/2 I. Okay, let's look at 3 examples, and then I'm done. So let's do 1 over 5 plus 2i, and then do 1 over 2 plus 3i, and do a 3 plus 4i over 2 minus 5i. Let's see if I have enough room. So the first one, 1 over 5 plus 2i, this would be a question that you get on your homework, and you want to get rid of the I at the denominator. So we want to multiply by 5 minus 2i, 5 minus 2i, and the numerator will just be 5 minus 2i because we are taking a 1 times that. And the denominator, remember we just need a first times first and last times last. So we get 25 minus 4i squared, which we get 25 plus 4. The top will still be 5 minus 2i. And my final answer, yes, top is still going to be 5 minus 2i, and the bottom would be 29. Denominator doesn't have an I anymore, so you're all good to go. Okay, let's try another one. What do we want to multiply to this? 2 minus 3i. 2 minus 3i, and then we get into the works. We have 2 minus 3i at the top because we're multiplying by 1, and the denominator would be 4 minus 9i squared. So the bottom would be 4 plus 9, and the numerator is 2 minus 3i. Final answer, 2 minus 3i over 13. Okay, last question. Last question. Now my numerator is not in 1 anymore, but it doesn't matter. We are only focusing on the bottom first. We want to multiply by 2 plus 5i, top and bottom. Okay, so the numerator, because we have two parentheses now multiplying each other, you got to do all of them because they're not exactly the same thing or different signs. So we have to perform all the arrows, which we get 6 plus 15i plus 8i plus 20i squared, all over. Multiply first times first, last times last, so we get 4 minus 25i squared. Okay, once you combine your like terms and get rid of these I squared, then we're good. Let me use green to emphasize this one. This is going to turn into negative 20, right? And the bottom right here is going to turn into plus 25. So our final answer would be negative 14 plus 23i over 29. final answer. Okay, so for your homework, Tuesday, again, we'll be having a meeting and it will be number 1 through 10 even. And then Wednesday is 12 to 20 even. Thursday, another 10 questions. And Friday is only 2 questions. Okay, and double check your due dates. And if you have any more questions, please let me know. Have a good day. Bye.